Hi, and welcome to part 3 of 3.12. In this discussion, we will be covering questions 8 and 9 of section 312. So what we want to talk about here is something called the zero product property, which means this. Sorry, I was talking while I was writing. That's never a good idea. Zero product property. So it goes like this. If I said to you, I have two numbers in my head, and when I multiply them together, my answer is 0. So I multiply one number times another, and I get 0. Most of you would realize that that means that at least one of my numbers had to be 0. So either my first number was 0, like 0 times some other number will give me 0, or some other number times 0 gives me 0, or maybe they were both 0. Okay? This is called the zero product property. If I know that the product of two numbers is 0, then it's guaranteed that either one or the other or both had to have been 0. Now this doesn't work for any other number. If I said to you, oh, I multiply two numbers in my head and I get 10, well, there's no guarantee of any number, because I could have done 1 times 10, I could have done 2 times 5, right? There's no guarantee. But for 0, there is a guarantee. So we use that property to be able to solve equations that are equal to 0. So I'm looking at question number 8, and they give me v plus 5 times v minus 18 equals 0. Well, notice that this is one factor that's being times by this factor, and all of a sudden I got 0. So this times this gave me 0, means that either this had to be 0, v plus 5 had to have been 0, or the v minus 18 had to have been 0, in order for that entire answer to be 0. So I would solve each of these smaller equations individually. So here I would minus 5, so I get v equals negative 5. Here I would have plus 18, so v equals 18. So I end up with two possible solutions, and here's why. If v had been negative 5, I would have put a negative 5 in here. So negative 5 plus 5 gives me 0. 0 times anything will give me 0 as a final answer. If v had been 18, then I would have plugged 18 in here. 18 minus 18 is 0. And even though this would be 18 plus 5, which is 23, it doesn't matter because 0 times 23 is still 0. So in this case, we have two solutions, negative 5 or 18. And when we put it into MyMathLab, we'll put a comma in between those two answers. This question isn't too bad because they already have the two factors and we just set them each to 0 and solve. But if we look at question number 9, we have to do a little more work. So this is where we put what we learned in part 2 together with part 3. So question number 9, I have r squared minus 30r plus 29 equals 0. So what's different about this problem compared to what we did in part 2 of this lecture series is that we have an equals 0. So this is an equation instead of a statement. If I did not have the equals 0, it would simply be a statement. In order to solve this, I need to first figure out what the factors for this trinomial would be. So I need to factor it like I did in part 2. I'm going to tack on that equals 0. I'll start with r and r. My plus sign tells me the signs are the same, and this sign is what they are. So in this case, they're both minuses. I take the constant term 29, and I need to find factors of 29. Well, it turns out 1 times 29 would be the only set of factors of 29. No other number goes in evenly because 29 is prime. So they both have to be minuses, and it turns out if I add them, -1 plus -29, I get -30, which is what I need because that's my middle term. So I'll have my -1 and my -29. So I have factored the trinomial like I did in part 2, but now I have to do one more step, which is to solve it, because this times this gives me 0. So either r minus 1 equals 0 or r minus 29 equals 0, and I must solve both of these equations. So I get r equals 1 or r equals 29. So I have two answers, and I would put them in with a comma in between. And that concludes this part of section 312, and there's one part to go.